I'm Ken Ribet. I'm a professor of mathematics at UC Berkeley. I've been at Berkeley since 1978, as a matter of fact, so I'm quite a senior faculty member at Berkeley. My specialty is arithmetic geometry, which includes number theory and algebraic geometry. I've worked quite a bit with modular forms and with abelian varieties and Galois representations. And my specialty is very close to the subjects that SAGE specialized in when SAGE was first introduced. I've been using SAGE for at least 5 years, and I use SAGE in two different ways. First of all, I use it in research in helping me to understand what's true and what isn't true. When I started out in mathematics, the only way you could look at a new scenario was to cogitate. Just think about, whether something might be true and think about how to prove it. And if you couldn't prove it, maybe there was something else that was true instead. And there wasn't really much in the way of experimentation. Whereas now, if you want to examine some scenario that you haven't yet thought about, you can run the first 30,000 cases and see what's true. And once you become convinced that something is true, it's much easier to be invested in proving the theorem. André Weil, who is one of the great mathematicians of the 20th century, said theorems are proved by mathematicians who believe in them. And SAGE is a really great tool to enable you to find out what to believe in. So that's one way in which I use SAGE. Another is that I've used SAGE repeatedly in teaching. I've used it 3 or 4 times in teaching the new cryptography class that we've introduced at Berkeley. And then because of my success in that class, I've used it for other classes, the number theory class that we teach juniors and the discrete math course that I teach to sophomores. And basically, if you look at a textbook and you find an example of some phenomenon, very often the example involves only small numbers, and often the example seems to be cooked up so that some miracle happens. And then you try to do another example, and you can't find the same miracle, and you become very frustrated. So in cryptography, when I do SAGE, first of all, I use much larger numbers than anything you see in a print textbook. And secondly, I can begin my program by choosing parameters randomly so that the students see I run the program in real time. The students can see that the numbers are being chosen without my intervention, and we can run the same program several times, and there are completely different numbers, and sometimes SAGE will take a very short time to do the computation, and sometimes you get less lucky and the computation takes a noticeable amount of time, so I can chat with the students while my laptop is churning away. And the fact that you can do these things is very impressive to students. And not only that, I release my code. I put my SAGE notebooks up on the web for the students to download, and so then they can experiment with SAGE by themselves. They can tweak my code, make it a lot better actually in many cases. And what's great is that the students can benefit from my experience, and I can benefit from their suggestions, and we can make code that runs faster and is much more transparent.